We're going to start with this recent exam paper. They wanted you first to look at the first 30 elements, and you need to pick elements like all the way from hydrogen here, all the way to element number 30, which is going to be, what do you call it? There you go, zinc, okay? So let's start with the first one. They said it's an element that makes up 78% of the air around us. Pretty easy, right? What are we going to call that one, Heidi?
Nitrogen.
So that is nitrogen, right? Again, you're only supposed to write the name of the element. You don't need to write the symbol or anything. Just say nitrogen. Then they said has atoms with electronic structure 281. So 281. What does that tell you about the period? It means that it's in period 3, right? So periods is going to be third periods, right? And what does that tell you about the group number? It's going to be group number 1, right? So for that reason, what are we supposed to pick? It's going to be period 3, 1, 2, 3, and group number 1. Therefore, it's going to be, so you could just simply add up the numbers, right? So 2 plus 8 plus 1 is 11, and that means it's sodium, all right? So I'm just going to write sodium. Next is it's extracted from hematite, all right? What's that element we extract from the ore hematite? That must be what? That must be iron, right? They said bauxite, it would have been aluminum, it's hematite here. Then it said forms an oxide, and this oxide forms like giant covalent structure. Every time I hear they're talking about giant covalent structure, do you know where am I supposed to look? Which group is the one that got these elements? Hawra?
Group 4.
Very good. And the element?
Silicon.
Must be silicon. Very good. So that must be silicon. So I'll just pick silicon. All right. I can't take carbon because they said the oxide forms the giant structure. Okay. Then they said it's a gas with the slowest diffusion rate. What am I supposed to look for? I am supposed to look for the highest possible molecular mass, right? So where are the gases in the periodic table? So you have hydrogen, you have group 7, nitrogen, oxygen, group 8. All of these are gases, right? So I'm just going to put a frame around these elements, and then we pick the one that got the highest molecular mass, right? So argon is not going to be included because it's not member of element 14. Not member of, because they wanted you only to pick up to atomic number 30, right? So that's going to be our choice here, right? So what am I going to choose? Any idea? Yusuf?
Argon.
Argon is good, right? Argon got a high atomic mass, right? I can't choose bromine. Bromine is not even a gas in the first place. Bromine is a liquid, plus bromine atomic number is 35. But you know why? If it is a gas, it has to be diatomic, right? Because also chlorine, when it forms a gas, right? Chlorine is actually, the molecular mass of chlorine is like 71. Therefore, I'd rather choose chlorine rather than argon, right? Because argon atomic mass is 18, but 2 chlorines, when it forms the molecular form, molecular gas, it would be more. It would be like 71. For that reason, I'd rather pick chlorine because as a molecule, it would have a higher molecular mass. Where is 80? What's 80 you're talking about? I don't understand. What's the 80? Bromine, again, they asked you to choose element up to element number 30. Okay? And again, bromine is, you can't choose argon, right? Argon is monoatomic. It's not going to form 80, right? Argon, all noble gases are single atoms. You can't choose argon. Okay? So what are the diatomic? Diatomic group 7, nitrogen, oxygen, fluorine, and hydrogen. Okay? Does it make sense? Do you know why, guys, we're choosing chlorine here? Okay. Next one is what? Next one, they said it has anhydrous chloride. turns pink when water is added. You don't know what we call those papers? The element here is cobalt, right? Cobalt chloride paper are the ones that turn from blue to pink when it's hydrated, right? So chose cobalt. Has aqueous ion forming white precipitate when added to silver ions. So when you add silver ions to it, it would form a white precipitate. So do you know what we choose, what we actually test with silver ions and is white precipitate? Faisal, Aisa?
Halides.
Yeah, so halide, very good. So it's going to be one of those halide, but it forms white. So what am I going to choose? Chloride, bromide, iodide. I would choose, since it said white, I would choose chlorine, right? Because it's ion, chloride makes AgCl, and AgCl is actually a white precipitate, okay? Good. Forms blue hydroxide, which dissolves in aqueous ammonia. Do you know what element forms blue compounds and it's dissolves in aqueous ammonia? Let me remind you of that's like the test of copper ions. Copper ions form blue precipitate, right? If it add excess ammonia to it, what happens to that blue precipitate? Dissolves and it forms like a dark blue solution. So again, blue alone would be enough to realize that they're asking you about copper. Add it to molten iron. So what's that element? If you add it to molten iron to remove impurities while you're making steel, what do you add to molten iron so that you could get rid of impurities? Hawra?
Oxygen.
Very good. It must be oxygen. We do that oxygen furnace thing, trying to get rid of carbon, trying to get rid of silicon, and all of these things. So that's why we call the oxygen furnace. Okay. Not calcium carbonate. They wanted an element here, by the way, right? They wanted a single element. I can't say I'm gonna add compounds. By the way, we don't add calcium carbonate to the oxygen furnace. We add calcium oxide. But again, I have to choose a single element. Okay. Used to galvanize iron. What's that element we use to galvanize the iron? What do we choose, Yusuf?
Zinc.
Must be zinc. Very good. Awesome. So do you guys have any questions? Do you still have doubt about that first page? All right. So next question. Next question, they gave us an equation and it involves magnesium carbonate. They said large pieces of magnesium carbonate that has been added to dilute hydrochloric acid to form carbon dioxide, water, and magnesium chloride. So they wanted you just for 1 mark to put the state symbols. So what are the state symbols am I going to put here, Heidi?
Magnesium carbonate is a solid, HCl is an aqueous, and H2O is liquid, and carbon dioxide is a gas.
Very good. So we chose for acids, it has to be aqueous. All acids are aqueous, right? I didn't have to think much because they said pieces, large piece. Piece sounds like solid, right? And water is a liquid, definitely. Carbon dioxide is a gas. Over here, look what they asked me to do. They want me to show the ionic bonding in magnesium chloride. So what am I supposed to do? I have to take a look at the periodic table. And as you can see, magnesium belongs to period 2. Since this belongs to period 2, then you would expect to have 2 shells of electrons. The other element I have here is chloride. It's in period 3, group 7. Therefore, it should have 3 shells and 7 valence electrons. So back to magnesium, I need to add like 1 extra shell here. Let me just make it neat. Here we go. So that is magnesium. These are the electrons, definitely. Okay. And that's the electrons of chlorides, definitely. And this is for magnesium, right? My plan was just to take those electrons and add them here to the chloride, and it's done, right? What about magnesium? Magnesium lost 2 electrons, right? The final shell here lost 2 electrons, okay? So it becomes what? Becomes 2 plus. And each chloride is going to be 1 negative, right? So that's the ionic bonding we have here. Is this clear? They wanted you now to show covalent bonds but this time they wanted you to show you in carbon dioxide. So carbon is in group 4, right? How many electrons it shares? It shares all of those 4 valence electrons. How many electrons are left unshared in carbon? There'll be 0, right? What about oxygen? Oxygen belongs to group 6. It has 6 valence. It shares how many? It shares 8 minus 6, so it's 2. And there will be 6 minus 2, 4 unshared electrons with oxygen, right? So therefore, I'm going to put the electrons that are shared with oxygen. So 2 here from each oxygen and 2 from each carbon. Okay? This means carbon is done, right? Carbon has shared all of the 4 valence electrons. Oxygen still has, as it says here, oxygen still has 4 unshared electrons, right? So for that reason, just going to put 4 here. Okay? Any question? All right. So the question now shifts from the bonding to rate of reaction. Look, they said, describe how the graph shows that the rate of reaction decreases as the time is increasing. So you need to take a look at the curve and try to figure out, like, what does that curve tell you about the rate of reaction? What was the rate like here at the beginning? What is it like here now? And finally, what was it becoming like this? What does that change in the shape of the curve tells you about the rate of reaction? Faisal?
The gradient gets less steep,
Very good.
decreases.
And that tells you what? Tells you that the rate of reaction is getting slower. So that's what I'm going to say. Yes, just that the gradient is less steep with time. Okay. Here's the fastest, here's slowing down, and here the reaction stopping. Next, they said, explain in terms of particles why the rate of reaction decreases as time increases. Here you have to be careful. You have to decide what's the limiting reagent, because always the limiting reagent is the one that determines the rate of reaction. So back to the initial part of the question, this was given at the very top of the previous page. They said, excess large pieces of magnesium carbonate, right? What does that tell you about the limiting reagent? Who's the limiting reagent here, Yusuf?
The hydrochloric acid.
Very good. So what do I say now? I say, well, hydrochloric acid, concentration of hydrochloric acid is decreasing, all right? Because the carbonate is in excess. So carbonate, you would always be left at the end of the reaction. You would always find what? You always find some carbonate left over. So the acid here is the one that got used up, or its concentration decreased first, and then it got used up, right? So say concentration decreases, then it gets used up. That's when the reaction stops. Okay, any question? Finally, they said, no, before we're still in the same question, on the grid, show what would the curve look like if you're changing from large pieces into powdered magnesium carbonate. How would that curve look like this time? Heidi?
It would be more steep, but it would level off at the same point.
So very good. 2 marks, steeper to the left, but then it would just level off. Why is it level off here? So steeper because of the large surface area. Levels off because we did not increase the amount of, or the concentration of any of the reactants. Concentration is still the same. It's just like we speeded up the rate here. Okay. Okay. All right. So next question, next part of this question, they're asking us to do a few calculations. First of all, they said find number of moles of the acids. They've given us 2 pieces of information. They gave us the volume, and this unit tells you what? When you see mole dm cubed, this means they're giving you the concentration. So what am I going to do with those 2? To find the moles given concentration of volume, what are you supposed to do? To find moles is the concentration multiplied by the volume. You just have to convert the volume into dm cubed. So what am I going to do here? I'll take the concentration, 0.4, multiplied by the volume. I have to convert the volume to dm cubed, all right? And you get the answer. So how much is the answer here? 25 over 1,000 times 0.4 gives you 0.01, right? This is the moles of what? This is the moles of the acids, right? So the moles of the acid here on the equation is 0.01. How many moles of CO2 you would have? So compare the acids to the carbon dioxide. What's the mole ratio? The mole ratio here is 2 and here is 1. Got it? So if this one is 0.01, what would be the moles of carbon dioxide? It should be what? It should be half of it, right? So 2 to 1, meaning what? What am I going to do with the 0.01? Just going to divide it by 2, okay? So 0.01 mole ratio divided by 2 becomes what? Becomes 0.005, okay? Is this clear? Then they said what? Then they said find the volume of the carbon dioxide. How would you find the volume of any gas? Find the volume of any gas. It's going to be the moles. Just found it now, right? 0.005 multiplied by 24, okay? It's just that they wanted to find an answer in cm cubed. So I'm just going to do the first step, 0.05 times 24, right? It's like what? This is like 0.005 times 24 is 0.12, okay? To convert dm cubed, always, the volume you get here, you're going to get it in dm cubed. To convert it to centimeter cubed, what are you supposed to do? Take it and multiply it by 1,000, right? So times 1,000 gives you 120 cm cubed. All right? You can't divide the molar mass by 24 to find the moles. No, to find the volume of any gas, you don't deal with the molecular mass of the gas, right? Okay, I already have the moles, okay? Second question, you want to find, how do you supposed to find the volume? You want to do what? For carbon dioxide, I have no information here, right? I haven't been given any information about the carbon dioxide other than it's being a gas. All the info given here was about the acid. All right. Question 3 talks about what? Question 3 talks about air. That's one major topic. Look, the 3 topics, they're big, important, obviously organic, air and metals. Those are like the core of this subject. Look at the question. They said, explain how nitrogen dioxide is formed in car engine. How does the pollutant nitrogen dioxide form inside the car engine? Yusuf, do you know how?
It reacts with the oxygen from the air under high temperature and pressure in the car engine.
Very good. So it's like the car engine is a closed chamber with the spark from that engine, the heat, the pressure, that causes that chemical reaction between nitrogen and oxygen, and it gives you what? Gives you nitrogen monoxide, right? Then it gets oxidized to nitrogen dioxide. So again, nitrogen and oxygen from the air, 1 mark, reacts in the heat of the car engine, it gives you nitrogen monoxide. State 1, look, they said nitrogen dioxide causes respiratory problems. If you inhale that acidic gas, it would give you respiratory problems. What other adverse effect that gas would have? As you guys are saying there, it would be what? It would be acid rain. So again, we get nitrogen monoxide becomes nitrogen dioxide, and then the nitrogen dioxide reacts with water vapor and it becomes nitric acid. Okay, what about the other source of acid rain? Other source is going to be what? You get first sulfur dioxide, oxidized to sulfur trioxide, and again, it dissolves in rainwater and forms sulfuric acid. And those would be the ones responsible for acid rain. Okay, so acid rain is the answer. All right, down there they said, name the type of reaction that is like induced by heat causing breakdown of compounds. So what we call this sort of chemical reaction that can only happen when it's heated and it gets broken down, breaks down the compound. Hawra?
Thermal decomposition.
Thermal decomposition. Very good. So 1 mark, you tell them it's called thermal because of the heat. Breakdown is decomposition. Okay. Question? Yes. What's your question?
Mr. Sulfur dioxide, it has to get oxidized to trioxide before it can dissolve.
Yeah, just like the contact process. To form the sulfuric acid, it's going to be sulfur trioxide that dissolves in the water, right? All right. Question. They said 1 molecule of urea breaks down to form 1 molecule of ammonia. See the equation. So you have like 1 mole, 1 mole. And they said there is 1 missing compound you would get here, which is also 1 mole. All right, they said 1 mole of each reactant and product. They said identify this other compound. So what are you supposed to do here to find that missing compound? What are you going to do? Take the, because I'm not supposed to put any number here, it's going to all have to be ones. Therefore, you have just to find the missing atoms. So like, what are the missing atoms on the left from those on the right? So try, for instance, here, I have 2 nitrogens, right? I have 4 hydrogens. I'm taking this compound on the left. Let me just show you. So I have 2 nitrogens, 4 hydrogens, and 1 carbon, 1 oxygen, right? What's the other compound I have here on the right? I have NH3, right? So minus NH3. What are you going to get as that missing compound? So you get 1 nitrogen, agreed. 4 minus 3 hydrogens becomes like 1 hydrogen. And how many, what are the other atoms missing now? There's carbon and there is oxygen, right? Again, it's very unfamiliar compound. It's just like we have to conclude it based on what? Based on the chemical equation. You can put the atoms in any order. It doesn't matter if you put the nitrogen first, the carbon second. They're going to accept it for sure. Okay? Any question? So we just worked it out from the equation. Anyways, they said, state the test of ammonia. How do you actually test for ammonia gas? So what are you going to do with that litmus paper, Heidi?
A damp red litmus paper turns blue.
Very good. So damp that litmus paper in water, put it in the test tube, and it turns blue. Okay, 2 marks. Just write it here. Next, they said, here's a chemical reaction. Balance that chemical reaction. Look, how are you supposed to do it? First thing is look at the one that they've already balanced. They've already balanced the water here, all right? And it says here that you got 12 water molecules. This means how many hydrogens have we got here? You got 24 hydrogens, right? So what's that number if you multiply by the hydrogens in the reactant would give you 24. So again, I need that number that you multiply by 3. It gives you 24 hydrogens for your reactant. What's that missing number, Faisal?
So it's 24 divided by 3, 8.
Which is 8. Very good. What about the oxygens? Again, I can conclude the oxygens the same ways. There's 12 oxygens on the left. Sorry, 12 oxygens on the right. So what's that number? If I multiply by 2, it gives me 12. It must be 6, right? So that must be 6. This means what? How many nitrogens do I have on the left now? There is like 6 nitrogens here, and you got 8. 6 plus 8 is 14. So what's that number? If I multiply by 2, it gives me 14. Must be what? Must be 7. Okay. All right. State how the equation shows that nitrogen dioxide has been reduced. So what evidence from this equation tells you that this nitrogen dioxide has been reduced? What do you think, Yusuf, is the answer?
To these oxygen atoms.
Very good. Yeah, it has lost its oxygen. It was nitrogen dioxide, and here it got reduced, right? So that is reduction. You can mention electrons. You can say, for instance, it's nitrogen here. What happened to it? It has increased, it decreased its oxidation number, or it gained electrons. So every way is acceptable. But again, always, 3 times, always mention electrons. When it comes to oxidation reduction, mention electrons, unless it's obvious, unless you got oxygen attached to the atom and so obvious that it has lost the oxygen, then oxygen would be given the priority here. Okay? But nonetheless, it's always related to electrons. Redox is related to electrons. Next thing, they said, state the meaning, means define redox. What's the definition of redox? Heidi?
The loss or gain of electrons.
Very good. So when electrons are lost and gained, right? Or when, like, for instance, loss and gain of electrons, oxidation reduction. If you just translate the word redox, oxidation reduction would also be acceptable. But there's a key word here, which is together, right? Simultaneously. So oxidation reduction must always happen at the same time. There is no oxidation unless you have reduction. Okay? So either you say redox is oxidation reduction or is the loss and gain of electrons, but you have to include at the same time. Okay. I'm not inventing that mark scheme here. It's just like based on previous exam papers. Here it says what? You got 135 moles of urea is stored in the tank of a car. Calculate the mass of the urea. This means what? This means you need to find the M in this mass formula. How do you find the mass of something like this? Step number one would be what, Isa?
You work out the MR.
Very good. So I'll work out the MR. So let's work it out together. So I say brackets 14 plus 1 times 2, right? Times 2. So this is the NH2 in brackets. Plus, what do I say I have? I have carbon 12 plus oxygen. Okay? Altogether, the molecular mass is going to be what? Altogether, it's a 60. Okay? So now that I have the molecular mass, what would be the next step to do, Aisa?
You multiply it by the number of moles, which is 135.
Very good. So to find the mass, it's moles times molecular mass. Okay. So I have 135 moles times 60. This gives me 1800 grams. How do I know it's grams? Because this formula gives you the mass in grams, right? The molecular mass is gram per mole and the moles, so you get the answer always in grams by default. How would you convert grams to kilograms? To convert your grams to kilograms, what are you going to do? You're going to divide by 1,000. So I take this answer and I divide by 1,000. It gives me my final answer in kilograms. That's what they want to do. Okay. All right. Any question? Can we say that nitrogen gained electrons for? Yeah, you can. You can say not reduction is gain of electrons because here the oxidation number is going to be 4, right? Cancel out the nitrogen. And here's the oxidation number is 0. It's a lone element. So gain of electrons. Now, this part about the, what do you call it, the catalytic converter is quite important. And it hasn't been there on the exam, in the recent exam. So revise it because, again, it's likely to come on your exam. So what are they being given here? They said there is a gas that you get with incomplete combustion. What do we call that gas you would get if there is some incomplete combustion? Saji?
Carbon monoxide.
Carbon monoxide. Very good. Now, question. They said there is this carbon monoxide we've just mentioned, and they said NO reacts with it. Nitrogen monoxide, let me write it here, reacts with carbon monoxide, and we get what? We get 2 gases that are non-toxic. What would be those 2 non-toxic gases that you would get by the reaction of nitrogen monoxide, nitrogen monoxide and carbon monoxide? Can you guys tell what would be those gases, Heidi?
Nitrogen and carbon dioxide.
Very good. So we get products, nitrogen and carbon dioxide, right? So we get 2, 2, and 2. They didn't ask for the equation. Okay. Question? Do you have a question, Faisal?
Mr. Why not nitrogen dioxide?
If you get nitrogen dioxide here, then what would be formed other than nitrogen dioxide? What would be the other gas?
Carbon? I mean carbon dioxide. I mean monoxide.
But they said non-toxic, right?
Oh.
Right. Plus, this is an important equation you have to study, right? That's some equation essential for this process. So in this process, what do? We pass those harmful gases, right, through the catalyst, platinum, palladium, right? And what do we get? We turn them into harmless gases. We turn it to nitrogen, carbon dioxide, and oxygen. And the reaction, just like the way I showed you here. By the way, this reaction is what? This reaction is, in terms of nitrogen, is reduction. Nitrogen here got reduced. In terms of carbon, it's oxidation. It's another redox reaction. Okay? Is this clear?
Mister, we can't say oxygen, right?
How would you get oxygen? Tell me how do I get oxygen and another harmful gases? So write oxygen here. And then what else am I gonna get?
It doesn't work.
All right, it doesn't work. Okay. All right. Next question is about cells and it's about electrolysis. So we've been given that cell, a battery, and they asked me here, draw an arrow on the diagram to show the flow of electrons. Here, you need to have basic knowledge of reactivity series, because always, the more reactive metal is what? The more reactive metal is the negative. It's where oxidation takes place. It is the anode, whilst the negative is the anode in a cell or a battery. Because how do you find an anode? An anode is always what? Anode is where oxidation takes place, right? Also, the anode, or where the oxidation happens, or where the reactive metal is, will always get smaller at the end of this process, okay? So again, one more time. What do I have here? I have two metals. Zinc is more reactive than iron. Then zinc is going to be the negative. Zinc is where oxidation is going to happen. And zinc is what? Zinc is going to be called the anode. And with time, what's going to happen to the size of zinc? With time, the size of zinc will decrease because of the oxidation, right? So being the negative means the electron is going to flow that way, okay? Harren?
Sir, can I answer the question for II?
Yes, please. Can you do it?
So it's Zn2 plus gives Zn2 plus 2E minus.
All right, very good. Almost correct. Can you change one little thing about it?
Zn plus 2E minus.
Yep. So this one would be raised, right? So zinc, because of zinc here, gets oxidized. Remember what we said? Gets oxidized. Gives those electrons. Those electrons travel in the wire and they get to the iron. Okay.
Yeah, and the zinc is like a solid, and the Zn2 plus is an aqueous.
Very good. That's why it decreases in size. Very good, Harren.
Yeah.
All right. Name a metal that can replace zinc to increase the voltage in this. So, like, I have zinc here. What metal would I choose to increase the voltage? The higher, the better, right? The higher the metal, the better. But I can't choose those three, right? Why I can't choose those three? They're way too reactive, right? So the best metal to choose to give you the highest possible voltage is going to be magnesium, right? So that's one here. I'll say use magnesium. What if I want to replace the iron here? What if I want to replace it with some other metal? Again, for the same reason. If I am to increase the voltage, then I go as down as possible, as bottom in the reactivity series as possible, to choose a metal that is low in reactivity. Something like what would I choose there, Heidi?
Lead.
Maybe lead, maybe copper. So anything lower than iron is acceptable, okay? Even any metal, okay? Again, below iron and above zinc. Either way, that would increase the reactivity, okay? You don't need the metal to be reactive for this cell. You need it for the this side. You just need it to conduct electricity and produce that voltage. So down at the bottom, what did they ask me? They said the fuel cell. That's another important question here. Fuel cells, they ask you, name the reactants used in the fuel cell and name the product, name the waste product in the hydrogen fuel cell. So again, in the fuel cell, what do we pump? We pump hydrogen, we pump oxygen, all right? What would happen to the hydrogen inside that fuel cell? Exactly the same thing that happened to zinc. Remember what happened to zinc? Hydrogen here gets oxidized into what? Into hydrogen ions. What would these hydrogen ions do? Those hydrogen ions flow in the cell, in the electrolytes, and they combine with oxygen, right? What about the electrons? Those electrons will flow in the wire. And where are they going to go to? They're going to go and combine with the oxygen and hydrogen ions. Together, what are they going to form? All of this together would form water as the waste product here. Okay? So once again, the reactants here are what? The reactants are hydrogen, oxygen, and the only waste product in the cell is water. Heidi?
Sir, so like above in the voltmeter thing, I solved the question today. It had like a bulb, and it said how will the light intensity increase or like change?
You have two options: acid, increase concentration of the acid, or move metals like distant apart in the reactivity.
Yeah.
Do you want to add something?
The better.
Which one is better?
Like if we choose like element like the metals apart. Like
look. officially is what? Officially, it's the battery is zinc copper. Okay. Higher reactivity magnesium, lower reactivity silver. And if you've been given two options, then you tell them I will increase the concentration of the acid. But these are like the official ones. All right. All right. Question, they said, name the process which uses electricity to break down aqueous molten ionic compound. What we call that process, Yusuf?
Electrolysis.
It's called electrolysis. Very good. Explain why the ionic compounds to be aqueous or molten. Why electrolysis only works if the ionic compounds have been either molten or dissolved into water. Faisal, do you know?
Yeah, so the ions are free to move, so they can conduct electricity.
Very good. So you can't have electrolysis unless you have free moving ions, and that can only be achieved if the ionic compound either got molten or dissolved into water. All right. Name three substances produced if you're doing concentrate electrolysis of concentrated sodium chloride. So what are the available ions we have here in this case? You have chloride, sodium, right? And you have the water, right? The two ions provided by water. What would form the cathode? What would form the anode, Saji?
Chlorine at the anode and hydrogen at the cathode.
Very good. So chlorine at the anode, hydrogen at the cathode, right? Why are we getting chlorine here? We're getting chlorine because the question says concentrated, right? When they say concentrated, then it means you're going to get the chlorine there at the anode. What am I left with now? I'm left with sodium hydroxide as my third product. So again, being a reactive metal, sodium does what? Sodium takes the OH, forming sodium hydroxide. Hydrogen forms at the cathode, and chlorine forms at the anode. Okay, is this clear?
Mr.
Chlorine, yes.
Would we call a sodium hydroxide another electrolyte?
Sorry.
Do we call the sodium hydroxide an electrolyte or just a third product?
Here is a product because my electrolytes, what's the electrolyte? Electrolyte is what you start with. All right. So observation, if you've been asked for observation, what would be the observation here? You would get a green, pale green gas at the anode, colorless gas at the cathode, and the electrolyte turns into what? Turns into a solution that turns universal indicator blue or purple. Now, question, if this was molten sodium chloride, how would the products change? So how would the products change in this case if it was molten? Isa?
You'd have sodium that forms at the cathode.
Very good. So the cathode would form sodium in this case. Again, if it was molten, then the cathode is going to be the metal. The anode would be always a halogen. All right. And the electrolyte gets used up. That's the case if it was molten. Okay. All right. Question 5. It's about hydrocarbons. They said, what we call short chain alkanes and alkenes. What would you call it if you're forming short alkanes and alkenes starting from a longer alkane? What do we call such a reaction there? Heidi?
Cracking.
So that is called cracking, catalytic cracking. As I said, write chemical equation for this reaction. What's the reactions like? They said decane, which is 10 carbons, forming ethane and ethene. Okay. So first of all, can someone determine what would be the formula of something called decane, knowing that it contains what? It contains 10 carbons. What would be the formula of that decane? Faisal?
C10H22.
Very good. How do you know? The general formula is CnH2n plus 2, right? So H is going to be 22. Now the question says that this decane breaks down, it cracks into C10H22. It cracks into ethane, which is what? C2H times 2 plus 2 is 6, right? And ethene, which is what? CnH2n, so C2H4. So we wrote the equation. Now all what we got to do is to balance it. So we need somehow to have the right number of carbons, hydrogens on both sides. Yusuf, do you have any idea how to balance it?
You have to, I think you have to put a 3 in front of the C2H4.
C2H4, I put 3. So this makes the carbons here 6. The carbons now 8, right?
Wait, sir, sorry. I
I'll
think
give you time. Yeah, it takes time. Right,
Yes.
don't worry. Hawra, do you have any other idea?
Yes, sir. Just put a 2 in front of C2H4.
Put 2 here. So this gives me what? Gives me 4 carbons, 6 carbons. All right. Still, we need some more, right? Atoms on the right. Faizan, do you have any other idea?
Sorry, sir.
So you put 4.
Put
I meant-
4. Put 4, yeah. Put 4 here. Yeah, when you put 4, this becomes 8 and 2, 10. 4 times 4 for the hydrogens, 4 times 4 becomes 16. And this 2 like adds up to 22, which is good, right? Thank you. Okay, so we actually balanced the equation. They said, name other product form. Now, take a look. They said ethane reacts with chlorine at room temperature to form chloroethane. This substitution reaction thing has been like in every single exam paper. So please study that on page 77. Again, name the other product, like when you react an alkane with chlorine, you do get chloroalkane, right? But what would be the name of the other product in this case? Can you name it there, Saji?
HCl.
HCl, hydrogen chloride. State the condition needed. What condition is needed for those substitution reaction that we're doing here? Isa?
UV light.
You'll need UV light. Now, another reaction, they said ethene reacts with chlorine and it gives me dichloroethane. State why this is an addition reaction. So how do you tell that this is like actually an addition? Like, what's the way you would determine this? Faisal?
One product forms.
Very good, because we had one product. Remember, with substitution, you would always get 2 products. But with addition, you break that double bond here. And what are you going to get? You're only going to get a single product, right? So Cl, Cl, H, H. Okay, good. All right. Any question? All right, so next question is about enthalpy. They wanted us to work out the bond enthalpy for this CCl, but they guided us, like gave us step by step to help us find the answer. So first thing they wanted you to do here is to calculate the energy needed to break bonds. If you're breaking bonds, this means what? This means you're breaking bonds in the reactants, right? Because bond breaking only occurs in the reactant. So I'm going to take a look at the reactants here and I count the bond. The best thing to do here is to do it on the table itself. So do it on the actual table. It helps you to find the answer and you don't lose track of what you counted and what you did not count. So once again, I have 4 of the CH bonds, so times 4. I have a single CC bond, so this one times 1. And I have 1 ClCl, right? So I have 1 times this. So altogether, this is what? You add them up, what are you going to get? You're going to get CH, which is 410 times 4, plus C double bond C, which is 610, plus ClCl is 240, right? So altogether, this is what? This is 2,490, okay? So this is the working out, bond being broken, and this is the endothermic part. That's the amount of energy we wasted while breaking those bonds in the reactants, okay? So now what am I gonna do? I'm now gonna use the guidance here. Look what it said. It said, use your answer and the energy change for the reaction to determine the energy released when bonds are formed. Where do we actually form bonds? We form bonds in the products, right? So how much energy was, like, how much is delta H of the entire reaction? I was told this, right? I was told it here, right? I was told that delta H, the change of energy for the reaction, is negative 180. So what am I going to do now? I'm going to take that equation, delta H. What is delta H? Delta H is energy broken minus energy released, right? Remember what was the delta H? I was given the number here, negative 180. Negative 180. How much energy was needed for the breaking of bonds? It is 2490, right? And that's the missing number, right? That's the energy for the formed, right? Energy broken, and this is the formed here. So I'm going to say minus X, okay? Why minus X? Because the bond formed here by default, it's going to be negative. So what am I going to do now? I'm going to just rearrange that equation. So rearrange that equation here. What was it going to become? X becomes like X is going to become negative. It's going to become positive 180, positive 249, right? Agreed? So altogether, how much is the value of X? How much is the energy that's been formed? Okay, let me just change it. That energy formed from the products. Altogether, you add them up, it's going to be 2,670, okay? Kilojoules. Are you following? Do you understand that second step we've done? We just wrote the relationship. Delta H is the energy that you have in the reactants minus the energy you have in the product. And we arranged that equation, okay? So EP was this answer. Faisal?
Mister, for the energy released and the bond forming, when do I put the negative sign?
If they said energy change, when they say energy change, then you can put negative, positive, right? When they say the actual energy, right? Energy can't be negative, positive, right?
Yeah.
Right.
Alright.
Energy change can be negative and positive, just like the way they put it here. That's a negative, that's an energy change here, right? Isa?
Sir, would I still get the answer right if I just use the table and then the product?
That's what I was worried about, because if I cancel, you mean just write the answer, not the working out?
No, I mean, so like looking at the product and then working it out, like CH, like working out the bonds and then adding them up for the product.
The only thing is, if you get it wrong, then you miss all of the marks, all of those 4 marks, right? So it's better to do it step by step. If you got this one wrong, the final one, you got it wrong, you would still get marks for the previous steps. Is that what you meant? Just like to find the final thing?
No, sir. I meant for like to work out the energy released when bond forming. Could I have done the same thing you did for the first one? Just like adding.
You can't. You know
up.
why? Because we have this one is missing. We don't have this value. CCl is not there.
Oh, okay.
That's why they wanted you to work out. Harren?
Sir, so we always look at what if they didn't give us the energy change? Do we just like
If they didn't give you the energy change, it would be impossible, right?
okay.
So either they give you all of the bonds, including the CCl, the one is missing, or they're gonna have to give you this number here.
Okay, so when we get the energy change, we just subtract.
You subtract the energy in the reactants all together minus the energy in the product.
Okay, thank you.
You're welcome. Delta H is the energy in the reactants minus the energy in the product. Someone is asking, I can make it negative X and remove from each side, right? And then I can make it negative X and remove the negative from each side, right? Yes, you can. You mean the way we arranged the equation here? Okay. Yeah, that's what I've done it here. I've done it that way. Question? Yes, better. Is it wrong if we find CCl first? How are you supposed to find it? Because there's no way you can find it unless you would do all of these steps, right? Why didn't we put negative sign? I wanted to show him that this is the negative. I'm not gonna put it forever. If you could send me that equation on WhatsApp and I can check it, see if it's right, okay? So now what will be the next thing? Next thing, use your answer here. Use that answer, 2670, and the bond energy value to determine the value of the CCl. So what would it be? Now I'm gonna look at the energy I have in the product. So what do I have there in the product? I have 4 CH bonds. So 4 times these 4. I have also what? I have C bond, right? I have this one here, times 1. So what's it gonna be? 4 times 410 plus the CC bonds, which is 350, okay? Plus what? plus these missing bonds, right? I don't have the value of the CCl bond, right? So what's it going to be? Plus 2 times CCl, right? Equals to what? Altogether, this is going to be equal to my previous answer because that's the energy released when bonds are formed. So all of this is worth what? 2670. So what am I going to do now? Just rearrange that equation. So you're going to say, well, 4 times 410, that is 1640 plus 350 plus 2 times CCl equals to what? Equals to 2670. Then take that 2 CCl here, and this is going to be equal to what? Just going to clean up this mess here. Here we go. So 2 CCl equals to what? Equals to 2670 minus 1640 minus 350, right? Altogether, this is what? Altogether, so let's do it. 2670 minus 1640 minus 350. Altogether is 680, right? So 2 CCl is like what? Is like, I forgot the number, 680. So one of it is equal to what? 1 CCl bond is going to be equal to 680 divided by 2, which is what? 340, right? Is it clear?
Mister, can I put the CCl as just X?
Yeah, put it as X, anything. They're not going to look at all of this working because they will look for this part here. They would look. But yeah, you can put it in any symbol. All right. So question about esters here. They said, state the name given to a family of organic compounds. They did include the CC bond here. It was included. There you go. 350, right?
No, sir, I meant in the answer itself, like when they made negative 1640, that's only the CH. It didn't include the CC.
Oh, yeah. That's what I got it. State the name given to family of organic compound with same chemical properties. What do we call this, Hawra?
Homologous series.
Homologous series. Explain why members of the same organic family, why do they all have same chemical properties? Like, why do alkanes have same chemical properties? Why do alcohols have same chemical properties? Faizan?
They have the same functional group.
Because they have the same functional group. State the name given to a formula like this. When you put N's and C's and hydrogen, what we call this arrangement, Yusuf?
General formula.
That's called the general formula. And they said, determine the N value of butyl propanoate. So how much is, that's the general formula, by the way, that's the general formula of esters. And the general formula, it also applies, the same general formula applies for carboxylic acid. So it could be used for either. Anyways, so what would be the N value? What would be the number of carbons in butyl propanoate? But is what? But is 4, right? Propanoate means what? Prop is 3. So altogether is what? That's a 4 and that's a 3, right? Altogether, this is a 7, right? Okay. Name technique to separate liquids. So what would be the technique to separate liquids from each other? Organic, non-organic. Do you know what we call that technique, Heidi?
Fractional distillation.
We call it fraction distillation, right? Now, you can't say they have the same chemical properties. That's not going to be an acceptable answer. You can't say they have the same chemical properties because they belong to the same homologous series. You did not add anything new, right? You have to indicate the reason why they have chemical property is because they got the same functional group, okay? Again, one important page in your book is this one, 74. It has all about the homologous series, the definition. So that's something you have also to revise and memorize very well. Question, they said, name the substance, like all esters are made by the reaction of different alcohols with the same substance. So what is the name of that substance that you reacted, methyl, ethyl, propyl, butyl? What all of these alcohols have been reacted with? All of them have been reacting with the same what, Sadi? It's going to be the same acid, right? Yeah, the same acid. So all of these, like this is going to be methanol, right? This is going to be ethanol, propanol, butanol, and they're all reacted with propanoic acid, which has this formula, right? C3OO, all right? That's propanoic acid. And again, what's the name of this alcohol here? Is going to be methanol, all right? Is this clear? Do you have any question from this page? I wrote the
Mister?
same. Look, Mina, the same general formula doesn't mean that they have the same chemical property. The only part of an organic molecule that determines its chemical property is its functional group, all right? So again, what makes an alcohol behave like an alcohol is nothing else other than the OH, all right? What makes an acid behaves like an acid is the COOH, right? So this is what we call the functional group. That's what determines the chemical property. Yes, what's the question?
Mister, did they give us that list in the question?
Did they give you what?
The list of the esters.
Where do you think I got it from?
Oh, okay, it's up.
All right.
Sorry, I didn't see.
They said state the term used to describe substances with the same molecular formula but different structure. What do we call those that have same molecular, different structure? Heidi?
Isomers.
We call them isomers. Name two esters with the same molecular formula as propyl propanoate. How many carbons you got there in propyl propanoate? Prop is always what? 3, right? And 3. So you got 6. Can you come up with names of esters that got total of 6 carbons? Isa?
Ethyl butanoate.
Ethyl butanoate. Ethyl is 2, but is 4, so that's 6. Very good. And what would be the other one? Yusuf?
Sorry, asking me? Oh.
Anybody else?
Butyl ethanoate.
Very good. So you reverse it, right? So either this is 2M4, 6. This is 4 and 2, which is also 6. Okay? And then comes that usual question they put at the end of every exam paper about polymers. They gave you diacids, dialcohol, and they wanted you to join them to form an ester. Okay? You can write pentyl methanoate. It's also acceptable. So how do you make that, what do you call it, polyester? Again, make sure you stick to the functional groups. So the white box is a dialcohol. So I'm going to keep that here. So that's a dialcohol. And the gray box is what? The gray box is the diacid. So I'm just going to keep the same one here. Okay? COOH, right? And then you condense them, right? So I'm just going to condense those together. What are you going to get? Race and form what? Form that ester bond. Don't forget to do this same thing from the side. So this is going to be erased, all right? And extend the bond here from the right. Same thing here, right? So that's a diacid and joined it to the dialcohol. And what are you going to form here? You're going to form that ester linkage, okay? Repeats COOH and COOH again, right? In the exam, you're not going to do it like the way I'm doing it now because it's such a waste of time. I just wanted to show you how you're going to draw it or how do you conclude it. But in the exam, you just need to be very familiar with the structure and draw it without much thinking, right? So again, how would you draw it quickly? You need to be familiar with this COO, right? That's the link. That's the ester link. And you're just going to put it where it should be, right? COO, right? That's going to be the first link. There's an oxygen here. Repeat, okay? And repeat. Got it? They said complete the diagram to show how these two molecules include all of the atoms and all of the bonds and all of the linkages. It's possible if you like to put that N here, right? It's not going to deduct marks from you. But again, they did not ask you to draw the polymer. They just wanted you to show a section. Look what they said, section from this polyester. They didn't ask for the entire polymer. So putting the N is not going to be like any addition. Should we remove the ester after the last linkage here? No, this is going to be open here, right? Both have to be open. There shouldn't be any oxygen here. Just keep it the way it is. What's the name of this polymerization? Remember where I was drawing? Every time I was removing a water molecule. So that's why it's going to be called condensation. And they said, name the polyester. Give an example of any polyester. Saji?
Pterylene.
Pterylene, very good. So again, the polyester and nylon, those must be very well. You should draw them like 5-10 times until you master them, like comes just straight away without much thinking. All right. I'm going to let you go now if you don't have questions.
Thank you, sir.
Bye.
Thank you, sir. Have a good
Bye,
day.
sir.
Bye. Good night.
Sir,
We're going to have
nylon?
one lesson on Saturday. We're going to have one lesson paper 4 on Saturday. We're going to have one on Monday and one on Tuesday.
Sir?
Yes?
So I was doing a past paper earlier today, and there's a question I didn't understand. Can you help me with it?
Can you send it?
On WhatsApp?
Yep, please.
Is this like the name of the past paper or the actual past paper?
Either. Do you remember what it is?
Yeah, it's May-June 2020, variant 2.
All right, just one second. I'm writing them the times. So Monday, 7:30, right? Tuesday, same time. Okay. I may change those, but the Saturday is going to be still Ramadan, right? So we're just going to keep the Saturday the way it is, and then we decide on the other days. I'm quite sure you're not going to take other lessons during those 2 days, right? Because just before your chemistry exam. So you probably have freedom here, right?